Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Optimizing PAPR Reduction in OFDM Systems through Optimum PTS phase rotations. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the research work that we have conducted in the domain of the wireless communication, where we are working on reducing the PAPR issue in the wireless communication. Here the optimization algorithm has been implemented to achieve the targets. So before starting the video, let's talk about that what we will cover into this video. In this video, initially we will talk about in which application areas the design system will be helpful and can be implemented. What are the real world scenarios where these works has been done. Other than that, we will discuss about whatever the codes we have designed, which files you have to execute, how to execute the code, and what are the software requirements to execute the simulations. Then what are the current systems are doing and what are the problems identified with them, how proposed system is working, what novelty we have introduced to it in order to handle the issues. Finally, an overall experimental outcomes and findings will be reviewed and will be shown at the end of the video. So let's start with the application areas. As in the wireless communication, this problem is basically arise that PAPR, peak average power ratio. So the application areas where this protocol can be helpful is in wireless communication, where the satellite communication, mobile communication, telephonic and radio broadcasting is there. So these are the application areas where it can be implemented in the Wi-Fi and the WiMAX, which is the short range communication systems. So there this OFDM system is there, because OFDM or the variant of the advanced OFDMs which are there in the 4Gs or LTs in the Wi-Fi systems, there this PAPR issues can be arised. So in the Wi-Fi or the WiMAX wireless networks, this implementation is there. For the DVB-T, that is digital video broadcasting, so the live video broadcasting that is happening, which is under the same domain, so in that area it is also very useful. For the digital audio broadcasting like radios, digital radios, and other communication through the audios where live audio has been transmitted from one location to another, so there it is very helpful. So overall application areas in which these works can be implemented in order to reduce the issues with the system are digital radios, digital television standard and digital video broadcasting, wired data transmission, WLANs data transmission, cellular data like LT systems, 4G systems. Even in the 5G, it is an integral part of the 5G systems, right? So these are the communication networks where this particular domain is useful. Now what exactly the issue is? These OFDM systems have the issues of PAPR, which is termed as peak average power ratio. So firstly, let's discuss that what is exactly the impact of PAPR. So high PAPR causes the interference and degrade the performance of the system while OFDM system signal passes through the amplifier. So whenever the signal has been passed in the wireless communication, the peaks of the power get raised, due to which there is an interference and degradation in the network. So let's see the diagrammatically that what exactly it is. Let's take this an example we have taken from one of the website. So here this is the very easiest way to understand that. Let's say this is an signal and this is the acceptable threshold range of the signal. So if the output signals power is gonna increase, you can see here the power regrowth is there, it is over the threshold value, so obviously this degrades the outcomes at the signal. So if it is it will not be controlled, then peaks will be degraded. So now there are certain systems in the models, but what exactly they are doing, like one of the example is clipping, they are just cutting this signal in order to get it within the range, but that can loss of the information, exact information will not be reached. So we need a system where the peak average power ratio should be controlled. So let's say the person who has implemented this, they achieved the black curve which is within the range and of the better outcome, so it should be the least. So this is basically the application area in the wireless communication and the problem of the PAPR and what exactly the PAPR is. So let's see the code that we have designed. So we will give you the folder name code under which there are a number of files with us. The whole code has been implemented in the MATLAB, so you must have the MATLAB software with you. So the MATLAB version that I'm using is 2019A. You can use 2015 or above, but make sure it should be the full version. In order to run the code, you just need to copy the path of the folder where the whole code has been placed, and then go to the MATLAB and paste the path here and press enter. You will see all the files those were there in the folder are now accessible in the current folder. The files that you need to run is like main PTS FA and different PTS FA. So these are the two scenarios which we have implemented, in which this is the main code and this is the analysis by changing the number of the iteration of the optimization algorithm. So now, in order to run the code, you just need to click on the main PTS FA. So when I'm running on this code, when I click on the run button, it will start executing the results. So you can see it start executing the factors. So in the meantime it is running, let's talk about what is happening around the world for the same domain. So people are working on different techniques for reducing the PAPR. The few of the common are like PTS, SLM, and many other. So but the problem with those is like they are not dynamic, and they are restricted to some certain configuration in the system, and multiple variants of those PTS, SLM or any other methods has been implemented. Even hybrid methods have been also introduced. The recent technology is like optimization algorithm and dynamic nature of the system. So what we have proposed, in the proposed system we have implemented the Firefly optimization algorithm in order to get the optimum outcomes in terms of the reduction of the PAPR. So PTS was in the literature one of the best technique which was getting better results in many of the scenarios. So we are improving the PTS method with us, where the initial OFDM system has been implemented and analyzed in certain parameters. So as you can see, this was the signal that we have generated. So one of the thing that we have done is like from the PTS is full form of the PTS that I'm going to show you. PTS PAPR reduction. So here is PTS, that is partial transmit sequence. So number of sequences has been generated at the transmitter end, and best of the sequences to be selected by the receiver end in order to get the reduced PAPR. So this is one of the method. Even in the recent years, still people are working on improving the PTS. So inspired from that we have implemented. So out of the set of the sequences, we are selecting the best sequence. Now how to decide that, and what is the method that can do that? So we have chosen the optimization algorithms. So we do have the optimization algorithms as a category, which are currently used in many of the domains in order to get the best solution of any of the problem, where the mathematically, numerically, the objective function has been declared and the best outcomes of that solution is there. So in our scenario, the problem is to reduce the PAPR and the solution is to select the best PTS sequence. So Firefly optimization algorithm, that is also termed as FA optimization algorithm, which is a Firefly algorithm which was proposed in 2008, but came popular in the recent years. So that's why we are choosing this one. So this is inspired from the nature inspired algorithm, that is Firefly's attraction to flashing a light, that how Firefly uh, attracts toward the light. So this is how the algorithm works. From the theory of these nature inspired algorithm is being used to select the best PTS. So here fireflies are like the sequence number and their light is basically the reduced PAPR. So this is what we have implemented. So let's see the code in short. So you can see Initially, the system of OFDM has been implemented. The number of packets that need to be transmitted, those has been given. Then the modulation has been conducted, and the process of OFDM, that is IFFT at the transmitter, then converting to serial to parallel, calculating the PAPR, has been conducted for the normal one. Then different PTS methods, PTS based combination has been made, and then by using the optimization algorithm, here you can see we have applied the optimization algorithm in order to get the best PAPR through the PTS sequence. So after this we got the best fitness value, and those, that is the final PAPR. So for every phase we are showing the results. Let's see what exactly it is. So this is the initial signal that we have generated. This is the BPSK modulated signal. This is when the IFFT or is applied at the transmitter end for the real and imaginary coefficient. This is for the PTS normal signal. This is the best PTS sequence selected by applying the FA on it. And finally the results are in terms of the PAPR. So here it is the proposed outcome in comparison to the original PAPR. This is proposed outcome in comparison to the normal PTS, and this is the comparison of the three. So you can see in all the three scenarios the PAPR is reduced in the proposed scenario, and gets the better results. So that is the basically objective of the system. So current systems are achieving around 6.8 of the PAPR, which is a good score. Even the further modifications are still possible by changing the communication channels, modulation schemes, to get the better results. So this is how we are working with the proposed work. Even in the different scenario, what we have done, we have analyzed the whole scenario by changing the count of the iterations to execute the FA. So the iterations that we have taken is like in the previous in the main section we have considered it to be 100. So here you can see the parameter that I have defined for the iterations are 100 in count. So here it is. So means iterations is 5 in count. So here the iteration is set to be 10, 20, 50, 100, 150 and 250. So it is running for multiple scenarios, and finally an analysis for the different scenarios has been conducted in the graphical form to show that proposed method with the iteration 10, 20, 50, how it works. So let's run this code. It will take some time to execute. So let's wait the simulation to get completed, so that an analysis among by varying the iteration how FA performed in reducing the PAPR will be there. So all the scenarios has been run for iteration 10, 20, 50, 100, 150 and 250. So here you can see the outcomes are with us. So here you can see these are the results. The original PAPR was around 10, and for the PTS it is around 7.5, but in our scenarios you can see the results are for 10, 20, 50, 100, 150 and 250. It is the variation among the results. Here you can see the results can be analyzed here. So at 250 it is around here you can see it is 6.6, and the best outcomes that we have achieved with the least PAPR is, here we can see it is 6.64, which is with the orange curve, and orange curve is like 10 iteration. It means the FA is performing better with the less iteration in comparison to the other existing method. So still modifications are possible into it for the research purpose or the industrial related applications. You can contact us directly and can get the details. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.